I love seeing large medieval armies in games, but when I look closer and see that the whole army is basically just one guy copy-pasted everywhere, I want to curl into a ball and cry. And I'm not talking about just one game. I keep seeing this again and again. And here, and in this game also, here as well, but you get the point. And these are games with enormous budgets and huge teams, so why do they ship armies that look like this? I mean, even I can do something better. What? You don't believe me? Fine, challenge accepted. I started by collecting references from real-life battle reenactments and movies. There's so much variety in shapes, colors, and textures. If we compare them with the in-game screenshots, you can immediately see they look miles apart. For example, just look at the height of each soldier in this screenshot. They're all of the same height. Small details like this are vital when we're trying to achieve realism. With references collected, I was ready to start. There's only one problem though. To represent an army, I'll need a bunch of 3D models. And if you've seen my previous videos, you know my modeling skills are of such high quality that they're way outside of the budget for this video. Luckily, I found these fantastic asset packs on the Unity asset store. They were exactly what I needed. Tons of variations, level of detail support, fully rigged and ready for animation. Also, all of these packs share the same underlying rig, so they can be used in combination. Easiest purchase of my life. The links are in the description if you want to check them out. After importing the models, my first goal is to generate just one soldier through code, and this is how I plan to do it. I will start with a naked soldier and then add a random wearable piece to each free body part. After that, I will add armor pieces on top, followed by the gear and weapons. For that, I need to tell the computer which 3D model is a clothing piece, which is an armor piece, gear, and so on, so I created a scriptable object that will represent one wearable piece. It defines its type, references its LOD meshes, and adds extra metadata about it. Now, I just have to create an instance of the scriptable object for each wearable piece. Nice. There's only one small problem though. There are more than 250 wearable pieces in this asset pack. Damn, it's going to be a pain to do all this work manually. And if there's anything I fear in this world, it's manual labor. So I decided to create this editor tool that automatically defines the type and the metadata of each piece. Then it creates a new scriptable object and saves it to the assets folder. With this tool, I should be able to complete this in no time. Well, this took a day or two, but I finally mapped them all out. With that out of the way, I quickly set up the first naive version of the algorithm that just picks a random wearable piece of clothing for each body part and adds it to the soldier. Let's see how this looks. Our soldier isn't naked anymore, which some may see as a progress. But there's a problem. The pieces are clipping through each other. I can easily fix this by manually adjusting the blend shapes of the gloves, but the algorithm doesn't know that it's supposed to do this. To let him know about it, I first created this affectance matrix that will tell him which wearable types should affect each other. That was the easy part. The hard part is telling him which wearables are compatible, which require modifications, and which ones are not compatible at all. This was a perfect opportunity to create yet another editor tool. Using it, I can select a wearable piece and it will show me all wearable pieces that can affect it. Then, I can mark the pair as compatible or not and specify modifications. After doing this for almost 5,000 combinations, I was finally done. Alright, let's see how our soldier is looking now. That's looking so much better. I feel like we're finally making some progress. By running the algorithm again and again, we can create a bunch of different soldier variations. Perfect. However, I can't just make random soldier configurations. Usually, the soldiers with similar armor and weapons were grouped on the battlefield into units. We can do the same thing by limiting which 3D models algorithm can use when creating soldiers. So, you can probably guess what I decided to create next. This editor tool helps me define which wearable pieces should be used when creating soldiers for a specific unit. It also allows me to quickly preview how a random soldier within the unit will look. Awesome, right? While I'm getting a pretty good feel on how the individual soldiers will look, it would be much better if I could see multiple soldiers spawn next to each other, so I could get a better feel for the look of the final unit. this was an excellent opportunity to create yet another editor tool that visualizes soldiers in a grid-like layout. And you can probably see it right now. After all this work, we've basically recreated the state of units in most games. A lot of clearly visible repetition, all soldiers of the same height. It hurts my soul. Let's start fixing this
ASAP as possible.
I'll start with the probably easiest fix, applying a unique height to each soldier. Height variety in humans follows a normal distribution, which basically means that the vast majority of the population has something we can call an average height, with a number of people being taller or shorter reducing as we move further away from the average height. To implement it, I followed the Box-Mueller transform, and here's how it looks in the code. First, I calculate the random normal distribution factor based on the Box-Mueller principle. Then, I use it to calculate the deviation from the average value. And let's see how the unit looks like now. First, let's crank up the possible deviation to see if it's working or not. Okay, it's definitely working. Now, let's try something more subtle and realistic. Okay, that's a bit better already, but we're not nearly done yet. The next, most obvious things are these repeating clothing patterns within the unit. So, what do you think we can do to fix them? Well, we could make more unique 3D models, so that each soldier has a unique piece of clothing, but that's really not a feasible solution. First, it would take a lot of time and effort to do so, however, that should never be a real excuse not to do something if we're striving for quality. So, the second and more important reason is that having a unique 3D model for each soldier is terrible for performance. So, what can we do? Well, we could maintain the same meshes, but make them look different by applying a different texture to them. This is a feasible solution and one frequently used in games. However, this will break draw calls due to materials being rendered with different textures. I will keep this as a valid backup option since we could create texture atlases, but I want to try out some other ideas first. My first attempt at this was using a desaturate filter in Photoshop to remove the current color, and then applying another color as an overlay. While this technically results in a different color of the model, I wasn't really satisfied with the result. It seems we lost some details in the process when we desaturated the initial color. I'm not gonna lie, I was genuinely stuck here for a bit. But then, another idea popped into my head. What if we calculate the luminosity of the color and then use it as a guide to apply a different one? I stumbled upon this generic formula for extracting luminosity from a color. It's based on the fact that our eyes are most sensitive to green, then yellow, and least sensitive to blue color. So I calculate the luminosity first, and then I can use it to sample a gradient of colors I manually defined. And here's the result. Damn, this looks like a totally different texture, and the details seem well preserved. I think this could actually work. I quickly set up a tool that would help me define gradients for each wearable piece and visualize them against the original color of the 3D model. You may think I'm overcomplicating things with all these tools, but it took me less than an hour to create color variations for all clothing pieces of the unit, so I think it definitely paid off. Let's see how the unit looks now. Damn, this looks so much better. Wait, what? Did anyone else just got the urge to rewatch American Pie again? With that fixed, let's take a look at the units again. We can definitely see some repetitions, but comparing it with the previous result, I think we can clearly see some progress. And we haven't lost almost anything in the performance department. After looking at the current results for a bit, I was thinking, can we somehow improve it without introducing more rendering complexity and creating new 3D models? And then I had this thought. What if we don't reduce repetitions at all? What if we just make them less noticeable? The repetitions are easiest to spot when two similar soldiers stand right next to each other. What if we would make sure that this never happens? Here's my idea. I will calculate how similar two soldiers are to each other. For example, if they have the same torso clothing piece and of the same color, I will add 10 points to their similarity. If they have the same piece but with a different color, I will only add 3 points. Also, if one soldier has an armor piece but the other one doesn't, I will subtract 10 points from the similarity factor. I will calculate the similarity factor for each pair of soldiers in the unit and then use this information to set up the configuration of soldiers that will provide the minimum possible similarity value for the whole unit. And with that, here's how the unit looks right now. This one change helped a lot to hide repetitions in my opinion. Just look at how the unit would look without it. Much less repetitions and a way more organic feel. However, you definitely wouldn't have a feeling that their formation is organic though. Let's tackle this next. During battles, the soldiers will try to maintain a specific formation, but due to human error, it wouldn't look this perfect. Let's mess it up a bit. Here's what I came up with. First, I put myself in the position of each soldier. What would I try to do if I were on the front line of this unit? Well, I would try to maintain a straight line with soldiers next to me and keep fairly close to them. Then, if I were in the next line, I would try to maintain a distance from the soldier in front of me as well as the ones next to me. Using that logic, I split the algorithm for the first row and the rest of the formation. For the front line, I spread out soldiers between the 2 points I manually specified. I then apply a small random horizontal and depth offset to each soldier, just to make it look a bit more organic and not so perfect. Then, for each other line of the formation, I place the soldiers behind the ones in the previous row with a slight random horizontal and depth offset, just to make it look more organic. Okay, this doesn't look that bad. However, I noticed something. The whole formation is swaying to the left for some reason. I decided to fix this by applying manual adjustments to the formation to center soldiers a bit more. Nothing too fancy here, just a bit of corrections. And with that, here's how the final formations can look. This seems quite organic and natural to me. It's also easily adjustable to achieve different results. Let's apply these formation properties now to the soldiers. Alright, this looks quite more natural. I love it. We're just getting better and better results. But we're definitely not done yet. I mean, everyone is in this default T-pose. Yikes. And they won't be able to kill any enemies without weapons, so let's throw some weapon animations into the mix. Now, when it comes to animation, let's just say I suck. Because of my non-existing animation skills, I need to make my life as easy as possible. After researching possible options, I stumbled upon Cascadeur. It's a software for creating animations that uses AI to predict where the rest of the body should be when you move one of the joints. This makes animation so much easier. Even a noob like me can quickly set up some decent poses. However, in order to enable this AI prediction, you need to properly set up your characters. Based on the use case, this can be a bit tricky, so I contacted this technical artist to help me out. And boy did he deliver. Just look at the sheer amount of weapons he managed to set up in a span of 1 week or so. Guys, if you need help with Cascadeur, hit this guy up. He's a joy to work with. He even created some animation poses for me, just to show me how it's done. Well, this just made my life 100 times easier. And to just seize the opportunity, I created yet another editor tool for extracting poses from animation clips. Okay, maybe I do have a little bit of a problem. Anyhow, here's how the unit looks with the animations applied. Wow! And let's compare it with the initial state to get a real sense of how far we've gone. Holy! This feels like night and day. As you can see, we've gone a long way from where we started, but do you still see something we could do to improve the look of the unit? Let me know in the comments below. Of course, this is only one unit. A proper medieval army needs to have multiple units and at least 10 to 20 times more soldiers than this. Well, I guess it's time to tackle performance and scale this up to oblivion. And we're going to do just that in the next video. See ya!